Moving on to the derivation for numerical aperture and acceptance angle. This is again the same setup. The black color cylinder is your cladding, the yellow color one is your core. We are only going to be taking one ray this time. The red color ray, it is incident exactly at the acceptance angle. Hence it makes exactly the critical angle here, and the ray travels along the core cladding boundary. So using the Snell's laws of refraction, which we studied for light in class 12, which also apply here, we are going to try and derive an expression for the angle theta A. So a quick brush up of the Snell's law. If you have two media having refractive indices x1 and x2 for example, and your light makes angle theta 1 in the first medium and theta 2 in the second medium, then what your Snell's law says is that x1 sin theta 1 equals x2 sin theta 2. So we apply that here. Your light is incident with an angle of theta A over here, and at this point it makes an angle theta R. The refractive index of your outer medium is N0, your core is N1 and your cladding is N2. So now we look at the air core interface. We assume this is air unless otherwise specified. So the refractive index is N0 and the angle is theta A. Here the refractive index is N1 and the angle is theta R. So N0 sin theta A equals N1 sin theta R. This is the first equation we get. So does everyone understand how this came about?
Yes.
Okay. Moving on, we now look at the core cladding interface. So refractive index N1, angle made here is theta C, and at the cladding refractive index is N2, and the angle, if you notice, will be 90 degrees. Why is it 90 degree? Because this passes this is the critical angle. The angle of incidence here is the critical angle. So the refracted ray will pass exactly along the normal. So this angle will be 90 degrees. So what is the next equation we get? One second. N1 sin theta C equals N2 sin 90 degrees, and sin 90 degrees is 1, so it is just N1 sin theta C equals N2. So this is our second equation. Clear so far? Okay. Yeah, so now we need to somehow find out an expression for theta A. That is what we are going to do now. Theta C will generally be given to you in the question. Even if it is not, you know there is an expression to find out the critical angle from the refractive index. And the refractive indices will most certainly be given to you. But this theta R will not always be given. So we want to eliminate all these unnecessary angles. Now when we look at this triangle, this is a right angle triangle. This is your 90 degree angle. So you notice that theta R and theta C, they add up to 90 degrees from the figure. So sin theta C will be the same as cos theta R, and cos theta C will be the same as sin theta R. Why is this? It's when two angles add up to 90 degrees, sine of one angle is equal to the cos of the other. Like sin 30 equals cos 60, that logic. So we have theta R here. We'll try to replace it in terms of theta C. Just give me a minute. Cos theta R, correct. Yeah, so we have N1 sin theta C is equal to N2. So we try to write that in terms of theta R instead. So N1 cos theta R equals N2. We have just replaced sin theta C by cos theta R, and that is valid because theta C and theta R add up to 90 degrees. So clear so far?
Yes.
Okay, just give me a minute.